Here we go. So day 2. Complex numbers, day 2. We're going to do 2 different things today. We're going to talk about complex conjugates, and we're going to talk about powers of I. First and foremost, the conjugate. A lot of times we'll call it the complex conjugate, because it is a complex number. So the conjugate of a complex number, a plus pi, is the complex number a minus pi. All you're doing to create a conjugate is you are switching the sign on the imaginary part. So for example, if you have 4 plus 2i, the conjugate would be 4 minus 2i. Right? If you have 3 minus 2i, it would be 3 plus 2i. Only the imaginary part sign is changing. The real part stays the same. Now, what is the conjugate then of 4 plus 7i? 4 minus 7i. Okay. Well, if I want to multiply those two, just to see what happens, and who knows what will happen. How would I multiply those two things? The complex number and its conjugate? FOIL. First, outside, inside, last. 16 minus 28i plus 28i minus 49i squared. Right? All I did, I FOILed it. Bless you. What do you notice what happens? The i's in the middle cancel out. Negative 28i plus 28i is 0. What happens to this I squared? Becomes negative 1. So 16 minus 49 times negative 1, which is 16 plus 49. What would that be? 65. So what equals 65? Oh, interesting. There's no i's left in our answer. Interesting. Okay. What about if I asked you for the conjugate of negative 3 plus 2i? Negative 3 minus 2i. Same thing. Let's multiply them just to see what happens. Who knows? If I FOIL these, negative 3 times negative 3 is 9. Negative 3 times negative 2i is positive 6i. 2i times negative 3 is minus 6i. And 2i times negative 2i is negative 4i squared. Once again, what do you notice happens? I's cancel in the middle. 6i minus 6i is 0. Well, then I get 9 minus 4 times negative 1. So remember, we replace I squared with negative 1 whenever we can. So I get 9 plus 4, which is 13. Weird. Again, I don't have any i's after I multiplied them. Do you think that will always hold true? Yes, that is one of the most important things about these conjugates, guys. So, do you notice a shortcut or pattern? We'll talk about that in a second. The most important thing is we're getting rid of i's. Because in a second, when we do fractions with complex numbers, we do not want any i's in our denominator. We'll talk about that in a second, like I said. But, hey, did you guys notice any pattern or shortcut you can maybe use when you multiply the conjugates? Can anyone figure it out by using those? Look at those 2 problems.
Add them. No?
Add what?
I don't know.
16 is what?
4 times 4.
4 times 4. 49 is what?
7.
7 times 7. 9 is what?
3 times 3.
4 is? So if you just take the real and the imaginary parts and you square them, you can just add them right together. So negative 3 squared is 9. 2 squared is 4. I can add them together and get 13. So there is a shortcut when you multiply these things. If you just want to multiply them together, add them together, you will always get a positive whole number. Right? With the complex conjugate, when you multiply it by its normal complex number, you should always get a positive whole number. There should be no i's left. Hey, if you multiply it by its complex conjugate and you have an I left, do you think you did it right? No. No. Go back and try it again. Double check your work, okay? Alright. Before we move on, What do you think the complex conjugate of 5i would be? What do you think? I heard some people say it, I heard some people not say it. If I wrote it as 0 plus 5i, what would the complex conjugate be then? Minus 5i. So it would just be negative 5i. So if you're just given the imaginary part, the conjugate is the opposite of it. If you're given positive 5i, it's negative 5i. Same sort of thing. If you need to put that 0 in front, do it. Right? That doesn't hurt you at all. Okay, any questions about the complex conjugate for right now? Okay, then, like I said, we're going to use it when we divide two complex numbers or you just have a fraction. Right? If you have a fraction, you have an I in the denominator. We do not want any answers with I in the denominator. We want real numbers in our denominators. So what we're going to do is remove it. How do you think we're going to remove it? What does it say? Multiply the numerator and the denominator by the complex conjugate for the denominator. We said if I multiply this by its complex conjugate, all of its i's should go away. But remember, when I do that in a fraction, I have to do it to both top and bottom. So if I want to solve this fraction, I want to make it as simplified as possible because I don't want any i's in my denominator. I'm going to multiply both top and bottom by 2 plus 5i. Remember, I am multiplying by the complex conjugate of the denominator. And what I do to the bottom, I must do to the top. Well, the top actually works out really easily. It becomes 2 plus 5i. And what do I have to do to the bottom to solve that out? FOIL. 2 times 2 is 4. 2 times 5i is 10i. Negative 5i times 2i is negative 10i. Negative 5i times 5i is negative 25i squared. Now, hey, instead of foiling every time and writing it out, if you want to do the shortcut, could you probably do that? Yeah, go right ahead. I'm going to write it out these first few times, though, just so you guys can see it. But I might start using the shortcut later. Okay? So in here, 10i minus 10i is 0. I'm left with 2 plus 5i over 4 minus 25 times negative 1. Because I squared will always become negative 1. Well, negative 25 times negative 1 is a positive 25, so I get 2 plus 5i over 29. Now, technically, that is not a correct answer yet. Why not? How do we write our answers when we're dealing with complex numbers? A plus bi. So what we want you to do is we're going to split this into two separate fractions. A real part and an imaginary part. 2 over 29 plus 5 over 29i. Now, you can put that I on top. You can make it 5i over 29. I have no problem with that. Or you can make it 5 over 29i. Either one works. The reason we do this is because if you can reduce these fractions, do it. Right? If you have that ability to reduce those fractions, do it. Otherwise, that's your final answer. Okay? Does that make sense? We're going to skip some of these. Is that okay with everybody? Okay. We're going to skip the next one, which isn't even on here anyway. Good to know. Okay. We're going to do 2 minus 3i over 4 minus 3i. Okay. We said we want to get rid of all of our i's in our denominator. So we do what? What do I want to multiply by here to do that?
4 plus 3.
The conjugate. So of the denominator. So 4 plus 3i on both top and bottom. Now on this one, I'm going to FOIL both the top and the bottom. It's not as nice as the first one. It's not just a whole number. So if I FOIL here, 2 times 4 is 8. 2 times 3i is 6i. Negative 3i times 4 is negative 12i. Negative 3i plus 3 times positive 3i is negative 9i squared. Now hold on, I multiplied by a complex conjugate, but my i's don't cancel. What's not the same? The conjugates, right? Yeah, we're multiplying by a complex conjugate, but it's not the top one, so this is okay. We are fine, right? You must multiply a number by its complex conjugate for the i's to cancel out. Okay? 4 times 4 is 16, plus 12i, minus 12i, minus 9i squared. FOIL the top, FOIL the bottom. So now let's simplify. The top, combine my like terms, 8 minus 6i plus 9 over, is everyone okay if I just turn that into plus 9? Right, I squared turns into negative 1, and then negative 9 times negative 1 would be positive 9. Is that okay with everybody? Okay. 16, my 12i's cancel, 12i minus 12i, plus 9 as well, right? I squared turns into negative 1, times negative 9 is positive 9. Does that make sense so far? I didn't lose anyone yet, did I? Okay, and lastly, right? 8 plus 19, or plus 9 is 17, minus 6i over 25. Put a box around it?
No.
No, split up. Real part, imaginary part. I'm going to go over here again. 17 over 25 minus 6i over 25. Cannot be reduced, so that's my final answer. Is that okay with everybody? Do we have any questions on that? Nope. Okay. If I go to the 6 over I, is that okay with everyone?
Yeah.
Question? Yes.
So yeah, for the first one you had the I like on like the
Correct. Either way works.
Oh,
If you want to put the I on top, it's perfectly fine. If you want to put the I on the side, perfectly fine.
Okay.
Okay? I'm okay with either one. So 6 over I. Same thing, I want to make sure my denominator does not have any i's in it. So I need to multiply by the complex conjugate of that denominator. Well, what's going to be the complex conjugate of I? Negative I, right? This is just like 0 plus I. So the conjugate would be 0 minus I or negative I. So on top I get negative 6i. On bottom I get negative I squared. Well, I squared turns into what again? Negative 1. Negative 6i over negative 1, which would be positive 1. So just negative 6i. If you want to put it negative 6i over 1, I'm perfectly okay with that as well. If you want to do 0 minus 6i, I'm okay with that as well. If you want to do 0 over 1 minus 6i over 1, that's fine as well. Any of those work, okay? Any questions on that? Do we want to do any more of those ones on the right-hand side? Otherwise, I want to go to some other stuff. Do we want to do any more? How about this? I will make sure that those are on Schoology, so if you do want to try them, you can have them on Schoology. Cool? Okay, let's try the next part then. Talking about the powers of I. So the powers of I, we all know what I equals, right? Technically it's a square root of negative 1. I'm going to just leave it as I though. Hey, what do we say I squared equaled? Negative 1. If you can't answer that yet, you're in hot water. Right? We talked about that yesterday. I cubed.
Negative I.
How do you get that? You put it in your calculator. You're one of those. You're one of those.
It's,
How do we get negative I out of that? Well, let's think about it. I cubed. That would be the same as I squared times I, right? Do we all agree? I squared times I to the first would be I cubed? Well, what's I squared equal to?
Negative I.
Mm,
Negative I. Negative 1.
negative 1. Now, negative 1 times I, Miss Larson, would be? What'd you just say? Say it again.
Negative 1. I. Shoot.
Negative I. Right? So I cubed is going to equal negative I. Because negative 1 times I is negative I. Now, same thing with I to the 4th. That would be the same as I cubed times I. Right? Well, I cubed is negative I times I, which would be negative I squared. I squared is negative 1. So it would equal positive 1. There's a reason I'm doing this, I promise. Alright, so don't be like, why is he showing us this? There's a reason. Just relax. I to the 5th is the same as I to the 4th times I, correct?
No.
What did we say I to the 4th was? 1. So 1 times I is going to be I. Here, I'm going to put a box around these. Okay. I to the 6th is the same as I to the 5th times I. Right? I to the 5th was I times I is, which is, hey, do you notice something happening here? There's a pattern forming. I, negative 1, negative I, 1. I, negative 1. It's going to be negative I, 1. There is a pattern there that happens. It's a cycle, right? Because every time you multiply by I, it's something getting closer to negative 1, which then turns into negative I, which turns into positive 1. Now, do you have to remember this pattern? No, absolutely not. But it does create sort of a nice little I wheel, which some students like to use when we do powers of I. You start at I, go to negative 1, negative I, positive 1, back to I. Each time we multiply by I, we go around our wheel. I would not suggest that in case we give you something like I to the 206th power. Because then you have to go through here and you have to go, well, I start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 206. That's going to take you forever, isn't it? Yes. So is the I wheel great for some of those smaller numbers? Yeah. The easier way, see our I wheel, I was a step ahead of them. That's our I wheel. The easiest way to figure out something like I to the 15th, I think, is to pull certain things out. Right? If I pull out an I squared from here, how many times does 2 go into 15 as a whole? 7. Does that get me to 15?
No.
No. So how do I get from 14 to 15? Plus 1. So I'm going to multiply by 1 more I. This will make sense in 1 second, I guarantee it. Hopefully. Alright? I squared is the same as what? What is negative 1 to the 7th power?
Negative I.
Negative 1, which times I would be negative I. Now, same thing. If you do that over here on the I wheel, you start at I as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I end up at negative I. Right? I think this way's a little bit quicker when we give you those bigger numbers. But if you want to do the I wheel, you can. Yes, ma'am.
Can't you just divide 15 by either 1, 2, 3, or 4, and then once you get a whole number, it's that 1, 2, 3, or 4?
Instead of just 2.
So you mean like, but what if it's a prime number? What if it doesn't divide by 4, 3, 2, or 1?
Well, it would divide by
It would divide by 1, technically. But they all divide by 1. Don't they?
Well, yeah, but they also can divide by a higher number, which would be 2, 3, 4. So like if it can't divide by 2, 3, 4, it
Well,
would be 1.
I'm not, okay, how about this? I'm not sure. We will check it as we go along, and if it works, then you can use it.
Okay.
But I'm not sure, so I don't want to tell you yes and then it not work.
Okay.
Does that make sense?
Yeah.
Okay. Okay. Sweet. Alright, let's try another one. I to the 22nd. If I take I squared, how many times does 2 go as a whole into 22? 11. That gets me 22, right? So I don't need to add any extra i's on. I'm good. I squared is the same as negative 1. And negative 1 to the 11th is negative 1. Hey guys, let's think about this for a second before we go any farther. Negative 1 to any odd power will always equal what? Negative 1. Right? Negative 1 to the first is negative 1. Negative 1 to the third is negative 1. To the fifth is negative 1. To the seventh is negative 1. Negative 1 to any even power would equal positive 1. Right? Negative 1 times negative 1, or negative 1 squared is going to be positive 1. Negative 1 to the fourth power will be positive 1. Negative 1 to the sixth power will be positive 1. So if you can remember this as well, it's also a nice little shortcut where you don't have to put it in your calculator. Negative 1 to the 7th, I know that's negative 1. Negative 1 to the 11th, I know it's negative 1. Alright? Does that kind of make sense a little bit? Do we have any questions on that before I move on? I don't want to go any farther until we all understand that. Cool? All of us that are sleeping, we're good? Okay? Alright, then, could we use that to simplify this problem here? How?
You find it.
Find it.
Find what I like.
It. On it.
The I to the A, can figure out what the I is.
Perfect. Yeah. Take each of these I values, figure out what they equal, and then plug them back in. Right? Like I to the 8th. If I simplify that using the i's to the second power, like I said, you don't have to use that way. How many times does 2 go into 8 as a whole? 4. That gets me to 8. 2 times 4 is 8. So negative 1 to an even power we said was positive 1. So if I go to rewrite this, I'd go 3 times positive 1 minus, and then I got to figure out what I to the 5th is. I squared goes into 5 as a whole how many times? 2. Does that get me to 5? 2 times 2? No, it gets me to 4, right? So I need to multiply by one more I. So negative 1 squared times I will be 1 times I, which is just I. So I to the 5th is the same as I. So I plug it in, minus 4I. Plus 7. Well, what's I squared going to equal? Negative 1, right? We should all know that one by now. If you don't know that by now, I'm going to be really upset with you. So I plug in negative 1. Well, 3 times 1 is 3, minus 4I. 7 times negative 1 is negative 7. So then I would just go 3 minus 7 is negative 4, minus 4I. Remember, the real part must come first. Does that make sense? Yes? No?
Yes.
Okay. Do we have any questions on that?
No.
We're sure?
Yep.
Okay. One last thing we're going to talk about. If there are 2 things to know about imaginary numbers, they should be what? You should all be able to tell me the first one. I squared equals negative 1. And we will replace it whenever we can. If you do not know that I squared equals negative 1, we are going to have issues. I squared equals negative 1. That's the most important thing we've talked about so far. The second thing. what we talked about today. When you multiply a complex number by its conjugate, hold on. This isn't very nice shade. You get a real number, and yes, it will always be positive. So when you multiply a complex number by its conjugate, you get a positive real number. Those are the two things. I squared equals -1. You multiply a complex number by its conjugate, you get a positive real number. Any questions on that? Okay. We got here at 25. We have an exit slot.
Yes.
There are 4 problems.